Hi everyone, and welcome to the second of two videos going through some past exam questions on redox reactions. As you can see from this question, there's an enormous amount of text at the top of this. I'm not going to read through everything here. What we're going to do is go and look at the actual question and then decide which bits we need to read. So the first bit here is saying, construct an equation for the oxidation of iron 3 oxide in step 1. So we need to have a look at step 1. So it's saying the student adds solid iron 3 oxide to a hot aqueous solution containing an excess of hydroxide ions. Okay, so if we're writing the equation then, so we're going to have our iron 3 oxide. So this is Fe2O3. And it said an excess of hydroxide ions. So there's going to be some hydroxide ions here. And what else does it say? The student bubbles chlorine gas through the mixture. Okay, so we need to add chlorine gas here. A solution forms containing aqueous ferrate ions and aqueous chloride ions. Okay, so these are going to be the products then. So we need to have our ions that it gave us, these FeO42-, and it also said chloride ions, didn't it? And then there's got to be somewhere we can see the hydrogen's going to have to go somewhere. So it must also be making water as another product. Okay. Right, so here's our sort of draft equation then, and we now need to try and work this out. So to be able to get this to work, we need to look at the oxidation number changes. So it told us this was iron 3 oxide, so the iron must be +3 here. The iron is obviously going to be the thing that's changing, because it's saying it's oxidation of iron 3 oxide. So what's the iron going to be here? Oxygen is -2, isn't it? Times it by 4 is -8. It needs to add up to -2. So the iron must be +6. Okay. And then the other thing that's going to be changing is going to be the chlorine, because it's going to be oxidation state 0 here because it's an element, and it's going to be -1 here. Okay. Right, the next thing we need to do is to make sure that the elements that are actually undergoing redox are balanced. So I've got 2 ions here, and I've only got 1 ion there, so that's going to have to be times by 2. So that means that the change in terms of oxidation has gone from +3 to +6. So that's a change of +3, but we've done it twice, haven't we? Okay, because we've got 2 ions. So the overall amount of oxidation is +6. If we then look at the chlorines, we need to balance the chlorines. We've got Cl2 and I've only got 1 chlorine here. So I need to have a 2 there. And then if we look at the overall change in terms of reduction, we've gone from 0 to -1, but we've done it twice. So the overall change there is -2. So now then we need to balance the oxidation and the reduction. Okay, they need to be equal. So if we've got overall oxidation of +6, we need to have an overall reduction of -6. So we need to times this by 3. So therefore I'm going to have to put a 3 here, and this is going to have to get changed to a 6. It's a bit scruffy. I'll write this out again properly at the bottom. Okay, so now we've balanced our elements that are actually undergoing redox. Now we just need to finish sorting out the oxygens and the hydrogens and so on. So what we've got here then, I've got 4 oxygens so far on this side. And on this side I've got 8 oxygens there plus the 1 from the water. So we're going to need more oxygens over here. We've got 8 plus 1. So we need 9. Let's just do this. It's going to take a while here to work this out. I think it's going to be awkward. So if I've got 9 oxygens at the moment, I've got 3 there. So that's going to have to be 6. If I've got a 6 there, that's giving me 6 hydrogens. So this needs to be a 3. But now this has obviously changed the number of oxygens. So now I've got 8 oxygens plus 3. So now I've got 11 oxygens. So if I've got 3 there, this is going to need to be 8. But that's now giving me 8 hydrogens. So now this needs to be a 4. Just give me 8 hydrogens there. And now I've got 12 oxygens. So if I've got, 8, 12, So if I've got 12 oxygens there, then I've got 3 there. So this needs to be a 9. But now I'm going to have 9 hydrogens. So I'm going to have to put a hut now. So let's make this 10. make that 10 oxygens. Now I've got 10 hydrogens, so this is going to have to be a 5. And so now I've got 8 plus 5, so I've got 13 oxygens on this side. 3 and 10 is 13 oxygens there. I've got 10 hydrogens and 10 hydrogens. There we go. So yeah, that's awkward for balancing. You can see that happens with these questions though. Okay, don't just give up halfway through. You need to keep changing it, and eventually it will get balanced. Okay. We need to check this though. To check we've done this right, we need to check that the charge is balanced. So I've got 10 negative charges on this side. These are both neutral. And on this side, I've got 2 lots of 2 minus. That's 4 minus. And I've got 6 minus here. So I've got 10 minus on that side. So that's good. So I'm going to write this out again just so it's clear here. There's not a lot of space in this question, although I've taken up most of it with my Redox scribbling. So it's Fe2O3 plus 10 OH minus plus 3 Cl2. 2 of this ferrate ion. 6 chlorides and 5 waters. Okay, that felt like a lot of work for 2 marks, but there we go. Right, part B. Write an ionic equation for the formation of barium ferrate in step 2. Okay, what's going on in step 2? We've added barium chloride to the solution. So this was this solution from here, so we're adding it to a solution that's got ferrate ions in it. A precipitate of impure barium ferrate forms. Oh, okay, so this is straightforward then. So we're using, it's an ionic equation, right? So it's just going to be the barium ions from the barium chloride. We do need to have the state symbols. And the ferrate ions, these ones from here. And it says these two are reacting to make a precipitate of barium ferrate. So it's literally just these two reacting together to make a solid. And it's 2 plus and 2 minus, so they just balance out. So that's nice and easy. Okay, and then finally here, step 3, what is the reducing agent? Okay, so if we look at step 3, what's going on here? Acidified aqueous potassium iodide. Okay, so here's the acid, there's the iodide. The barium ferrate flow from here, reacts as it's shown. Okay, we get this bunch of stuff. Okay, so we've got to identify the reducing agent. So we need to look at the oxidation number changes. So barium's not going to change. It's going to be is 2 plus there, is 2 plus there. Iron is quite likely to change. So here, the oxygen is -2, isn't it? So times 4 is -8. The barium's going to be +2. So that brings it down to -6. So the iron must be +6. And here the iron is +3. So that's good. Hydrogen's +1. It's going to be +1 everywhere. It's going to be the iodine here. Iodine is -1, and here it's 0. So the iron has been reduced, and the iodine has been oxidized. So it was asking us, what is the reducing agent? So the reducing agent is going to be the thing that reduces something else. The reducing agent is itself oxidized. Okay, the reducing agent reduces what it's reacting with. So in this case, it must be the iodide ions that are the reducing agent, because they have reduced the iron from here. Okay, so the reducing agent is the I minus, and the explanation, it does say explain in terms of electrons. So we need to be careful here. So I minus is the reducing agent because it is oxidized. The thing that is oxidized is the reducing agent. So in terms of electrons, then it loses 1 electron. And it gives these electrons to the BaFeO4, the barium ferrate, to reduce it. Okay, so it's reduced the barium ferrate by giving it electrons. This has been reduced because it's gained electrons. The I minus is the reducing agent because it's lost electrons, it's been oxidized. Okay, got a different question here. Again, it's one of these, we've got various different steps in the equation, so they tend to like these sort of multiple step things, kind of confusing. Again, I'm not going to look at this yet, I'm just going to look at the question first. So a redox reaction takes place. Add the correct number of electrons to the correct sides of the incomplete oxidation and reduction half equations. Okay, so we just need to add electrons into these. So this isn't too bad. I don't think we need to read this. We can work this out from here, right? We just need to look at the oxidation number changes. So here, the oxygen is going to be -2, and times by 2 is -4, so the manganese must be +4. And so the manganese must be the thing that's changing. Here, the oxygen is -2 again, times it by 4 is -8. It needs to add up to -2, so this must be +6. So if it's gone from +4 to +6, it's been oxidized. Oxidation is loss of electrons, so the electrons need to be on this side. And if it's gone from +4 to +6, then it's lost 2 electrons. So then in this one, this should be the reduction in theory, so we should have electrons on this side. Let's just work this out. It must be hydrogen's always +1 and oxygen's always -2, or 99% of the time. So it must be the chlorine that's changing. So if oxygen's -2, times by 3 is -6. It needs to add up to -1. So chlorine must be +5. And here the chlorine is -1. So the chlorine has definitely been reduced. So it should be gaining electrons, that's right. And if it's gone from +5 to -1, then it's going to have to gain 6 electrons. Okay, so that wasn't too bad. Right, and finally this question here. We've got 2 redox reactions of iodine. Iodine's reacted with oxygen to form a compound with a molar mass of 333.8. Okay, we're going to have to work that out, aren't we? In alkaline conditions, iodine disproportionates. Remember this, so this means the same element is both oxidized and reduced. Okay, it forms iodide ions, iodate 5 ions, and water. Okay, construct equations for this. And we don't need state symbols. Okay, good. So iodine's reacting with oxygen. Okay, so iodine is I2 and oxygen is O2. And we need to form a compound with this molar mass. Okay, so we're going to need to work this out. Let's get our periodic table. What is the atomic mass of iodine? So iodine here is 126.9. Okay. So if it's 0.8, I'm going to guess that's 2 iodines. Let's just work that out. 126.9 times 2 gives us 253.8. Let's just check if I add on another 126.9. Yeah, it becomes 3. That's too big. Okay, so it's definitely only 2 iodines. It's going to be I2, and then it's just how many oxygens do we need to make it up to 333.8. So 333.8 take away 253.8 is 80. Divide that by 16. Oxygen 16, isn't it? It's 5. Okay, so it must be I2O5. Okay, and then we just need to balance it. The iodine's fine, so we just need 2.5 oxygens. Okay, that's not too bad. So that's the key thing, is just using the molar mass here and finding the atomic mass of iodine. Right, reaction number 2 says in alkaline conditions. Right, so if it's in alkaline conditions, it means we're going to have OH minus ions. Iodine disproportionates, so iodine is I2. And it's going to form iodide ions, so that is I minus. Iodate 5, so we need to work out what this is, and water. Okay, so what is this going to be? So iodate, remember anything with 8 on the end of it, sulfate, carbonate, it means oxygen. So this is iodine and oxygen. So this is iodine and oxygen. And if it's iodate 5, then it means that the iodine is oxidation state +5. Okay, well, we know that oxygen is -2. Okay, so the question now is how many oxygens are we going to need? This is going to be a negative ion, isn't it? We've got no metals. If it's an ion that just involves non-metals, it's going to be negative. So we need this to have a negative charge. So I'm going to need 3 oxygens. I'm going to go -2, -2, -2. So that adds up to -6. So I don't have a single minus charge. So this is my iodate 5 ion. And I think we've seen that before in one of these other redox questions. Okay, so the more you do these kind of questions, instead of this being, oh my God, what the hell is this? It's like, oh yeah, I think I've seen this before. So they do kind of reuse the same kind of chemicals. So that's what that's going to be. And water as well, it said. Okay. Right, so now we need to build this up. We need to look at the oxidation number changes. So what's going on here? This is going to be the iodine. Well, the iodine's being oxidized and reduced, isn't it? Okay. So we've got iodine is 0 here. It's -1 there. And it's +5 here, obviously. Okay. So we need to make sure that the element that is undergoing redox is balanced. So I've got 2 iodines, and I've got 1 and 1, so that's fine. And then we need to make sure that the total amount of oxidation is balancing the total amount of reduction. So it's being reduced by -1, and it's being oxidized by +5. So that means this is going to have to be multiplied by 5 for the reduction to balance the oxidation. Okay, so I'm going to have 5 I minuses here, and so therefore that gives me a total of 6 iodines. So this is going to have to be a 3. Okay. Right, and then we just need to balance the oxygens and the hydrogens. So here I've got, again, we're going to probably need to be a bit patient with this. Let's see how awkward this is going to be. I've got 4 oxygens on this side, so I'm going to need to put a 4 here. That then gives me 4 hydrogens, so I need to put a 2 there. But now I've got 5 oxygens, so that's going to be a 5, but it's not going to be a 5 because it's going to give me an odd number of hydrogens. So let's try making that a 6. Then I've got 6 hydrogens, so that means that needs to be a 3. And I've got 6 hydrogens, 6 hydrogens, 3 oxygens, and 3 oxygens is 6, and 6 oxygens. Okay, good. That wasn't too bad. We check, don't we? We check that the charges are balanced. I've got 6 minuses here, and 5 + 1, I've got 6 minuses on that side. So we're good.